going to be a very long video. So you're basically going to talk about the pH scale, and we already touched a little bit on this on our video on hydrolysis of salts, right? So just a revision. pH scale ranges from 0 to 14. Then here in the middle we have 7. So substances that are basic or bases have a pH of greater than 7. So all of the substances from 7 up to 14 are basic substances, or sometimes they call them alkaline, right? And then the substances that have a pH lower than 7, so it's less than 7, the substances from 7 up to 0 there are acidic substances, right? Cool. So in the way we define pH in chemistry is that pH is used to measure the concentration of H or hydrogen ions or those protons. So remember, if it's a concentration, we put it in that square bracket, right? So it's basically a way for us to tell whether a substance is acidic, basic, or it is, neutral, right? So if a substance is neutral, it will have a pH of 7. That's something that I forgot to mention, right? Cool. So how do we then calculate our pH? We simply use this formula. We say the negative log of the concentration of hydrogen ions, or sometimes you just say the log of our hydronium ions H3 plus, right? So that's the constant. This is the concentration of the hydrogen ions. This is the concentration of the hydronium ion. That's why it's in a square bracket, right? So let us just take a quick example. So we have a question over there. It's quite straightforward. It says to us that we have to calculate the pH of a solution where the concentration of hydrogen ions is 1 multiplied by 10 to the power of minus 7 mole per cubic decimeters. This is cubic decimeters, right? So we know that we said we can just calculate pH by simply using this formula. I'm not sure if you've given this. I'll check at the back of your question paper, but I don't think so. So we're just going to say the negative log of the concentration. That concentration is 1 multiplied by 10 to the power of minus 7. And you'll actually find that that value is 7. So what is that value telling you? If the pH is 7, it's telling you that our solution is neutral. So now let us take a bit of a slightly challenging exercise in terms of calculating pH. So a question says to us, in a volume of 162 cubic centimeters solution of ethanoic acid, the following equilibrium is established. So we have an equation here where acetic acid or ethanoic acid reacts with water to form that ion, there's CH3COO minus plus that hydronium ion, right? Cool. And then the number of moles of CH3COO minus is found to be 0.01 moles, right? And we have to calculate the pH of the solution. So remember, to calculate the pH, we simply use the negative log of maybe hydrogen atoms or hydronium ions, right? So we have to find the concentration of the hydronium ions. We're not given it. It means that we will actually have to calculate it first. So how do we do that? So this is where we're gonna use our knowledge of stoichiometry a little bit and say, all right, we know the number of moles of CH3COO, and now we're looking at the ratio of this to H3O plus, right? Cool. So we find that the ratio is actually 1:1. What is this implying? This is implying that the number of moles of CH3 is going to be equals to the number of moles of H3O plus, because the ratio is 1 to 1. For every one mole of this, there's one mole of that, right? Meaning that the number of moles of H3O plus, the hydronium ion, will also be 0.001 mole, right? Cool. So now we know the number of moles. You can see that we can actually calculate the concentration using this equation, where the concentration of the hydronium ions is nothing but the number of moles. It's number of moles, all of it divided by the volume, right? So we were given the volume of that solution was given to us as 162 cubic centimeters, right? But we know we can't use it this way. We have to first convert it to cubic decimeters. To do that, we simply divide by 1,000, and we get how much do we get? We get 0.162 cubic decimeters. This means that to find now our concentration, we will simply say H3O plus, so that the number of moles is going to be 0.001, all of it divided by 0.162, right? So if you put this in your calculator, essentially going to come to a very long number of multiple digital points, decimal points, right? So we can just round that off number, and we find that value to be 0.062, right? So this is concentration, so it's in mole cubic decimeters. So we're not done. Remember, our goal is to find the pH, right? So the pH, the negative logarithm of our concentration, hydronium ion concentration, which we have found there, 0.0062. And if you put this in your calculator, you find that it is 2.21. So what is it telling you right now? It's if this value pH is less than 7, it means our solution is actually acidic, right? Cool. And this actually brings us to the end of this video.